Hello to all. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today we know that 2023 Nobel Prize for Chemistry has been declared. Moge Bawendi, Louis Bruss and Alexei Akimov. Mogi Bawendi, Louis Bruss and Alexei Akimov. All these three scientists belong to USA. Won the 2023 Nobel Prize in Chemistry for their discovery of clusters of atoms known as quantum dots, now used to create color in flat screen light emitting diode lamps, LED lamps, and devices that help surgeons see blood vessels in tumors. The prize awarding academy said scientists had added color to nanotechnology when matter is used on an atomic or molecular level in manufacturing, and their finding held great potential in many fields. Actually, when size decreases, size of the substance decreases, and when it comes at nano level, means when size decreases, becomes small and smaller, and when it comes in the range of nano level, means 10 to the power minus 9 meter, then their many properties change. Actually, these properties size dependent. It's optical properties, many properties, optical properties, mechanical properties, many properties change. Electronic properties also change. Then here we should know what is actually quantum dot. What is a quantum dot? Quantum dot, also called semiconductor particles, a few nanometer in size, having optical and electronic properties that differ from those of larger particles as a result of quantum mechanics. They are a central topic in nanotechnology and material science. When the quantum dots are illuminated, by ultraviolet light, means UV light, an electron in the quantum dot can be excited to a state of higher energy. In the case of semiconductors, quantum dot, in the case of semiconducting quantum dots, this process corresponds to the transition of an electron from the valence to the conductance band. The excited electron can drop back into the valence band, releasing its energy as light, and this light emission is called photoluminescence. The color of the light depends on the energy difference between the conductance band and the valence band, or the transition between discrete energy state when the band structure is no longer well defined in quantum dots. Quantum dots are also called artificial atoms. By coupling two or more quantum dots, an artificial molecules can be made, exhibiting hybridization even at room temperature. Precise assembly of quantum dots can form superlattices that act as artificial solid-state materials that exhibit these solid-state materials exhibit unique optical and electronic properties. This point is, you have to understand, quantum dots can formed, actually it is artificial atom. More than two atoms can form, more than two quantum dots can form an artificial molecules. And artificial molecules can be made exhibiting hybridization even at room temperature. Precise assembly of quantum dots can form superlattices that act as artificial solid-state materials that exhibit unique optical and electronic properties. Potential applications of quantum dots include single electron transistors, first. Second, solar cells. Its application, first application is in a single electron transistor. Second, in solar cells. Third, in LEDs. Fourth, in laser. Fifth, single photon sources. Sixth, cell biology research microscopy. And seven, in medical imaging. Their small size allows for some quantum dots to be suspended in solution, which may lead to their use in inkjet printing and spin coating. Some quantum dots pose risk to human health and the environmental. Some quantum dots pose risk to human health and the environment under certain condition. Okay, actually this theory of this discovery is old, but development of this particles, means artificial atoms, you can tell atoms are this artificial solid state material, that is new, and it is very, very useful. Already application I have discussed. Its application is in a single electron transistor, in solar cells, in LEDs, in laser, in single photon sources, in cell biology research microscopy, and in medical imaging. Correct? Thank you.